Welcome to my lesson where we are going to look at Mathematics Lesson Part 1. In today's lesson, we are going to look at Topic 1, which is on sets. So let us define what a set is. A set is a collection or group of similar objects or elements. So let's go now to set notation or presentation, or rather set language, for you to be able to understand the concept or the topic of sets. First of all, you need to understand set notation or set presentation or set language. A set is denoted by a capital letter such as A. The objects of a set are enclosed in curled brackets, and separated by commas. For example, V is equal to open brackets A, E, I, O, U, close brackets. So this set can be read as the set V containing elements A, E, I, U, V. And actually, if you look closely at this set, we can also say set V is a set of vowels in English. Let's also look at elements or members of. So elements or members of represented by this symbol here. This symbol here means is an element of or is a member of. For example, 3 is a member of odd numbers. So what are odd numbers? These are numbers not exactly divisible by 2, or numbers that give a remainder when divided by 2. Let's also look at not an element or member of. So this symbol here means not an element or member of. The symbol here means is not an element of or is not a member of. E.g., 3 is not a member of even numbers. What are even numbers? These are numbers divisible exactly by 2. So these are numbers divisible exactly by 2. Let's also look at universal set represented by this letter here. So universal set is the set which contains all the elements under discussion. E.g., if V equals a set of vowels and C equals set of consonants are given, then the universal set of these two sets is alphabet, a set of alphabet elements. Let us also look at intersection of set represented by this symbol. Intersection of a set is the set of elements common to all the original sets. So if you have 2, 3 sets, the sets of elements common in those set, in those three sets, is called intersection set. For example, if set A has got the elements 1, 2, 3, 4, and 5, and set B has got the elements 2, 4, 6, then the elements that are common in both sets are 2 and 4, and therefore we can say the intersection of set A and B is equal to 2 and 4. Let us also look at the union of sets represented by this symbol. So a union of sets, it is a combination of all elements of the sets being considered. So the combination of all the sets being considered is known as a union of sets. E.g., if A contains the element 1, 2, 3, 4, and 5, and B contains the element 2, 4, and 6, then the union of A and B should contain all the elements combined. So, however, we do not write an element which is common in two sets twice. We just write it once. Let us also look at empty set represented by this symbol or curled brackets that are empty. So, an empty set is a set which has no elements. For example, A is a set which contains triangles with more than 3 sides. Of course, there are not triangles with more than 3 sides. Therefore, set A is equal to an empty set represented by curled brackets that contain nothing, or this symbol here, which also represents or simply reads empty set. Let's look at also finite set. A finite set is a set which contains a limited number of elements, or whose elements are known exactly. For example, letters of the alphabet, of the English alphabet, equals ABC dash 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 comma XYZ. This is a set, or this set is finite, because we are able to tell all the elements which belong to the letters in the English alphabet. Let us also look at an infinite set represented by this symbol. An infinite set is a set which contains an unlimited number of elements. So in other words, the elements in an infinite set cannot be known exactly. Some can be known, while other elements cannot be known. E.g., natural numbers. Natural numbers, we cannot know. They start from 1, 2, 3, 4 going forward. No one knows when or where or which is the last number in the natural numbers. So this set is an infinite set. So let's also look at subset represented by this symbol. A subset is a set which also belongs to another set. The symbol here means is a subset of. For example, if V is a set of vowels and A is a set of A, E, I, then we can say set A is a subset of set B, meaning that the members which are in set A are part of the members which are in set V. The number of subsets, n of the bracket subset of a set is actually n 2 to power n, where n is the number of elements in the set. So this simply means that you can tell how many subsets a certain set has by using this formula. Number of subsets is equal to 2 to the power n, where n is the number of elements in the set. So for example, if set A has 3 elements, then number of elements is 3, which also means that the number of subsets is equal to 2 to the power 3, which also equals 2 times 2 times 2, which equals 8. So this means the number of subset equals 8. So meaning this means that if a set has 3 elements in it, then there are 8 subsets in that element. So for example, if set A contains the elements A, B, C, then subsets of A are A, B, C, A, B, A, C, B, C, A, B, C, and also empty set. So since set A contains how many elements? 1, 2, 3, then how many subsets should it have? 8. So let's count 1, 2, 3, 4, 5, 6, 7, 8. And take note that an empty set is also a subset. So let's continue. Let's look at complement of a set represented by that symbol. So it is a set of elements that are not members of the set being considered, but are members of the universal set. So this is how we denote it, e.g., if the universal set contains natural numbers less than 10 and set A contains prime numbers less than 10, then the numbers which the elements of the universal set are actually 1, 2, 3, 4, 5, 6, 7, 8, 9 as natural numbers less than 10. Then what are prime numbers? Prime numbers are actually numbers that are divisible by 1 and themselves. So prime numbers are numbers which can be divided by 1 and themselves without giving a remainder. So prime numbers less than less than 10 are 2, 3, 5, and 7. So these numbers can only be divided by 1 and themselves so that they don't give out a remainder. So A is a set of prime numbers less than 10, which are 2, 3, 5, and 7. So now, if we say A complement, meaning we need to consider the elements which are not for A but are in the universal set. So which are these? 1, let's check. Also 6, mean 1, 4, 6, 8. So these are the elements which are not in set A, which are 1, 4, 6, and 8 and 9. Alright, so let's continue. Number of elements. If a set A is a finite set, the number of elements in the set A is denoted by n open brackets A close brackets, which means number of elements of set A. E.g., if A contains the elements which are letters of the English alphabet, and the English alphabet contains 26 letters, then that means that the number of elements of set A is 26. Now let's move to Venn diagrams. So this is the diagrammatic representation of sets. The universal set is represented by the rectangle, while ordinary sets are represented by a circle. So in a Venn diagram, which is a diagrammatic representation of sets, a universal set is represented by a rectangle, while any other ordinary set is represented by a circle. So for example, here, this rectangle here represents a universal set represented by this symbol, and this circle here represents set A containing A, E, and I. So this is how sets are represented diagrammatically, and this kind of representation is what we call Venn diagram. Let us look now at the set relationship presentation using Venn diagram. So for example, let us look at this diagram here, which contains the universal set also containing set A and set B. So now you can see that the universal set is shaded, including all set A and set B. So what does this mean? This means that the shading is actually listing the elements that are in this particular Venn diagram. So the elements that are in this particular elements simply are the elements found in the universal set. So this is interpreted as universal set. Let's look at another situation here. So in this situation, we have set A shaded. So set A is shaded. Now, as we have set A shaded like this, how do we interpret this? So here it just reads as the set A. This can just read as the set A, because this shading here is shading for set A. It's a shading for set A. So it can be written as set A. So we are listing, when we shade like this, meaning we are trying to list only the elements that are in set A. So how about this one? So this diagram here, when the circles overlap each other like this and we shade the overlap or the intersection, this overlap is called the intersection. That means we are interested in this shaded part, and this shaded part is the intersection of set A and set B. which can be written as A intersection B, or which can be read as intersection of set A and B. So let's look at this another example. So here we have also the universal set, which is this rectangle. We have also set A, which is shaded, and also set B, which is shaded. So in this shading, we are asked to interpret or to list the elements of set A and set B. So such kind of listing, where you list the elements of this set and another set, is called union. So here they are asking you to list the union set of set A and set B, which can be written as the union of set A and B. So union of A and B. That's how it is supposed to be shaded. When they shade like this, meaning they're asking you to list the union of set A and B. Lastly, let us look at this also arrangement where the shading is done of they want us to list the elements which are in the universal set, but they are not in set A, but they are also in set what? In set B. So in other words, if they don't want us to list the elements which are in set A, they want us to list the elements which are in the union set and set B. That means they want us to list the set A complements. They want us to list set A complements. So we indicate or write this as A complement, meaning this is how you indicate when you shade A complement. It's supposed to be shaded like this, that these are the elements that are not part of A, which can be read as complement A. Right? Let's move. So let us look at one example as we conclude of a question from the topic sets, and this example is going to come from 2020 Examinations Council of Zambia, Examination for General Certificate of Education Ordinary Level, which is GCE. So let's see the question. Question number 6. Use set notation to describe the shaded region in the diagram below. So we have three sets here: the the universal set, then we have set P, set Q, and set R. And they have decided to shade this part here. That's the one they want to list. So in other words, this part is actually the overlap between set Q and set R only, and this overlap is the union set of set Q and set R, which can be written as set Q intersection R. So this is the intersection set between set Q and the R, which can be written Q intersection R. So you read this one as intersection of set. Sorry, this one is supposed to be intersection. So you read this one as Q intersection R. So you read this one as Q intersection R, which can be written as Q intersection R. So to keep this video short, I will end here with this lesson, and I hope if you got value in this video, please can you like, share, and comment. But if you never got any value, please give a thumb down, and also comment in the comment section. Let us know where we went wrong, and I promise you we'll be able to improve in the next video. See you next time. Bye bye for now.